This is Geometry, section 6.3, deciding if quadrilaterals are parallelograms. So there's really no new material in this section. It's really just building on what we did in the last section. So we're really just stating the converses of everything we stated in the last section. So in the last section we said if you have a parallelogram, then 4 different things are true. In this section we're saying if any one of those 4 things are true, then you have a parallelogram. So the first one was if your opposite sides are congruent to each other. So if you have a quadrilateral and you don't know if it's a parallelogram, but you know that the opposite sides are congruent, then you can say it's a parallelogram. Same thing happens if you have a quadrilateral. So I just give you this 4-sided shape and I tell you that the opposite angles are congruent to each other. So opposite angles congruent, then that means that quadrilateral is a parallelogram. Same thing if I give you this and I say these 2 angles are supplementary, these 2 angles are supplementary, these 2 angles and these 2 angles, all of the consecutive angles are supplementary to each other, has to be all of them. So all consecutive, meaning right next to each other, all consecutive angles supplementary, then you have a parallelogram. And the last one, if your diagonals bisect each other, so if you know this piece is equal to this piece congruent to this piece, diagonals bisect each other, then you have a parallelogram. So in these 4 examples, we're trying to decide, is there enough information to show that the parallelogram is, that the quadrilateral is a parallelogram. So we know all of these shapes have 4 sides. We don't know if they're parallelograms or not. So if not, what else would we need to show that it's a parallelogram? So here we've got a 4-sided shape. We know this angle is congruent to this angle. This is not enough, so no, because we would need to know that angle B is congruent to angle N also. So we would need to know that these 2 are congruent and that these 2 are congruent. We need to have both pairs of opposite angles congruent to each other. In this next one, we've got 88 and 92 next to each other. So if I add up 88 and 92, I do get 180, so these 2 angles are supplementary. However, we know nothing about these 2 angles up here. So this one doesn't work either. We would need to know one of these 2 angles, because if we had these 2 angles, so opposite angles need to be congruent. So this one would need to be 88. This one would need to be 92. If we knew one of those, then based on the rules we learned in the first section of this chapter, we could add these 3 up and subtract the total from 360, because we know a 4-sided shape adds up to 360 degrees. So if we had at least one of them, then we could conclude that this was a parallelogram. So we would need either that the measure of angle P is 88, or that the measure of angle A was 92. In this one, we've got this diagonal going this way is bisected because this piece is congruent to this piece. However, we do not have that this piece is congruent to this piece. So this is also no. We need to know that both diagonals are bisected. In this last one, these triangles again mean parallel, so we know the top is parallel to the bottom, and these sides going sideways are congruent to each other. The tick marks mean congruent. This is not enough either, because we need both pairs of sides to be congruent or parallel, not one of each. This does not work. We can't have one side parallel, one pair of sides parallel, and one pair of sides congruent. We have to have one or the other, both parallel or both congruent. In this example down on the bottom, it says, show this quadrilateral cannot possibly be a parallelogram. So based on what we know about parallelograms, let's just assume it was a parallelogram. If it is, then these two angles are opposite from each other and they need to be congruent. So if we set 3x equal to 2x plus 50, if I subtract 2x to solve for x, I get 3x minus 2x is x, and 50 is left on the other side. So this gives me x equals 50. Knowing that opposite angles are congruent gives me that. Knowing that consecutive angles are supplementary, that would allow me to take this angle and add those together and set them equal to 180. So if I do that, 3x plus x minus 32 equals 180. If I add these together, 3x and x is 4x minus 32. Add the 32 to get it over to the other side. This would be 212 equals 4x, and when I divide by 4, I would get x equals, let's see, 53, which is not the same as 50. So if I use one rule, I get one thing, and if I use the other rule, I get a different thing for x. So there's no way that this shape right here could be a parallelogram if I can't apply all of the different rules that we learned to it. Another example, show that the shape right here, HELP, is a parallelogram in two different ways. First way, show that both pairs of opposite sides are parallel. So in order to show that two lines are parallel on a graph, we need to show that they have the same slope. So we would need to compare HE and PL. So if I find the slope of each of those, I'm just going to count it since we have a graph. So slope of HE is going to be rise over run. So 1, 2, 3 over 1, 2, 3, 4, 5, 6. So 3 over 6 or 1/2. So the slope of PL should be the same as that. Let's check. Up 1, 2, 3 over 1, 2, 3, 4, 5, 6. Same thing. So these two are parallel, HE parallel to PL. And we have to check the other two sides. So the slope of HP and the slope of EL. Let's check. HP, now I'm going down. So down 1, 2, 3, 4, 5, 6, 7. Oops, counted too much. 1, 2, 3, 4, 5, 6 over 1, 2. So down means it's a negative slope. So negative 6 over 2, which reduces to negative 3. And from E to L, 1, 2, 3, 4, 5, 6 over 1, 2. So it's the same thing. So these two are also parallel. HP parallel to EL. The next way we can prove is to show that the midpoint of diagonals is the same point, because if the two diagonals bisect each other, then their midpoint is the same point. So if we roughly draw those in, we can find the midpoint of each using the coordinates. So if I write out the coordinates of all of these, this is 1, 8, coordinates are up here, or we can just look at the graph. E is 7, 11, L is 9, 5, P is 3, 2. So I want to find the midpoint of E and P and the midpoint of H and L. We can just use the midpoint formula for that. So the midpoint formula is we take the x coordinates of these 2 points and average them. So 1 plus 9 divided by 2. Then take the y coordinates, 8 plus 5 divided by 2, and see what we get. 1 plus 9 is 10, divided by 2 is 5. 8 plus 5 is 13, divided by 2 is 6.5. Next one, so we need to prove that the midpoint of EP is the same thing. So if we use the same formula, midpoint formula, take the x coordinates and average them. 7 plus 3 divided by 2. Y coordinates and average them. 11 plus 2 divided by 2. 7 plus 3 is 10, over 2 is 5. 11 plus 2 is also 13, divided by 2 is 6.5. So the midpoint of each diagonal is the same thing, which proves that this is a parallelogram. All right, a proof using what we've learned about parallelograms. All the statements are filled in for us. We just need to fill in the reasons. So we are given that GS is parallel to BH. So we can mark that on the diagram. We're also given that GS is congruent to BH. So that's what we're given. We're trying to prove that this shape is a parallelogram. So the next statement says angle 1 is congruent to angle 2. Well, since these are parallel, just like we talked about in the last section, these two angles, going back a while, a few chapters ago, were called alternate interior angles. So that is why those are congruent. They're alternate interior angles. They're inside these two parallel lines, and they're on the opposite side of this transversal. Next, GH, this line down the middle, is congruent to itself. That reason we called a reflexive side. We use that when we were proving triangles are congruent, which is exactly what we're going to do right here, because now we've got this side congruent to this side, this angle congruent to this angle, and this side congruent to this side. So that gives us side, angle, side to prove that these two triangles are congruent to each other. SGH right here, and BHG right here. These two triangles are congruent to each other. Now that we've said those two triangles are congruent to each other, we can say that any of the corresponding pieces of those triangles are congruent. So I can say GB is congruent to SH. The reason we used was corresponding parts of congruent triangles are congruent, or CPCTC. Now that we've proven the triangles are congruent, we can say any of the corresponding pieces are also congruent. And finally, this is a parallelogram. Well, we've just shown that these opposite sides are congruent, and we already knew that these opposite sides were congruent. So we've got opposite sides congruent. Since we've proven both pairs of opposite sides are congruent, that means this is a parallelogram. So what we started off with here, the fact that we've got this pair of sides is both parallel and congruent, that's also an extra theorem we can use to show that parallelograms, that quadrilaterals are parallelograms. This isn't going to come up a lot, but it's just an extra way to know how to prove that a given quadrilateral or four-sided shape is a parallelogram. So if we know that it's quadrilateral and one pair of sides is both parallel and congruent, then we can say that this is a parallelogram. So if you've got one pair of sides both parallel and congruent, this is a parallelogram. The example we had on the previous page was that you've got one pair is parallel and the other pair is congruent. This does not work. This works. If you've got one pair, the same pair is parallel and congruent, that works. One pair parallel, one pair, the other pair congruent does not work.